In the first part of implicit differentiation, we are going to discuss the basic concept of implicit differentiation. So when you write an equation or function, you express y explicitly in terms of x. What does this mean? This means we want to isolate y on one side, so we have y equals to something something x, right? So let me give you two examples. So let's say y equals to e to the 3x plus 2 plus sine of x. This is expressing y explicitly in terms of x. So we have one y only on one side, and then we have a bunch of x on the other side. Or y equals to cosine of 5x times ln of 2x minus 1, right? So this is y, express y explicitly in terms of x, y on one side and all the x on the other side. So this, for these two equations, you can easily take the derivative of y with respect to x. dy dx is you take the derivative of the equation y and treat x as an independent variable. Alright, so that is what we did in the past. So let's say I give you another equation. So what about equation of a circle? So let's say we have x squared plus y squared equals to 25. This is equation of a circle with center at 0, 0, and then radius is equals to 5. This one I can easily express y explicitly in terms of x. So all I need to do is I isolate y on one side, right? So I can put the y on the left side. So we have 25 minus x squared. To get rid of the square of y, we take the square root on both sides. Since the square is the 2, the power 2 is even, we have to use plus or minus x. So this is solved equation for y explicitly in terms of x. How about solving x explicitly? That means I want to put x on one side. So x stands on one side by itself. So that will be x equals to 25 minus y squared. I take the square root on both sides, and then I do the plus or minus. So if you just consider the plus, all right, we take the derivative. Just consider the plus. Don't worry about the minus. So this one, I can take the derivative of y with respect to x, right? So this, you can bring down the square, and then 25 minus x squared, 1 half minus 1 is negative 1 half, and then by chain rule you take the derivative of the radicand. So 25 minus x squared, the derivative is equals to negative 2x, and then this one you can take the derivative of x with respect to y. So you treat y as an independent variable. So let's consider the plus only. So we bring down the 1 half, so that will be 25 minus y squared, negative 1 half, and then the derivative of 25 minus y squared is multiply negative 2y. So we can easily take the derivative, right? What if you are not able to do so? You are not able to have x stands alone on one side. You are not able to have y stands alone on the other side. So let's say we consider another function. How about this? We have x to the fourth. So we have x to the fourth plus y to the fourth equals to 2xy, and you don't know what implicit differentiation is. I am asking you to give me dy dx. So that means I want you to take the derivative of y with respect to x. Can you do it? Let's try. So in order to do the dy dx, first I have to isolate y on one side. So this one, I would like to have y to the fourth, and then 2x y minus x to the fourth, right? Looks easy. And then all you have to do is you raise both sides to 1/4 power. So y is equals to the fourth root of 2xy minus x to the fourth. So since y raised to an even power, we have to use the plus or minus. Can we do dy dx now? Can we do that? Can I take the derivative of y with respect to x? The answer is no, you cannot do that if you do not use implicit differentiation, because this one is you did not express y explicitly in terms of x. The evidence is I still have a y on the other side. There is no way to get this y out. That means there is no way to have y on one side, one y only on one side, and then on the other side you have bunch of x. That is impossible. And then how about put x on one side? So put x on one side, I can have x to the fourth equals to 2xy minus y to the fourth. All right, and then this one, how about How about this? Can we isolate x on one side? The answer is no. I don't think that is possible. So this one you have x, and then you have plus or minus the fourth power 2x minus 2xy. Let's erase that, 2xy minus y to the fourth. So this one you are not able to do the derivative of x with respect to y because there is an x in there. That is impossible. Okay? So in this situation, when we are not able to put y itself on one side or x by itself on one side, we have to use implicit differentiation. When you are stuck in this situation, we have to use implicit differentiation. So implicit differentiation helps me to take the derivative anyway, even though you are not able to put x or y on one side by itself. So we don't need to worry about this algebra. Using implicit differentiation, we can just go ahead to find the derivatives. So let me give you a very basic example, all right? I am going to use the equation of a circle. So this one, let me switch color, switch to a yellow. So I have x squared plus y squared equals to 25. It is this one I know it is possible to put y on one side, right? So you can have y equals to plus or minus the square root of 25 minus x squared. But this, we are not going to consider this step at all. I will just go ahead to take the derivative on both sides with respect to x. So to do so, let me draw the derivative notation. So this one we have d dx. I am taking the derivative on the left side, treat x as an independent variable. And then d dx, the derivative of the right hand side, I treat x as an independent variable. So using the sum rule, we have, go back to yellow. So we have d dx, the derivative of x squared, plus the derivative with respect to x of y squared. I know that gives you a big question mark. And then the derivative of 25, which is equals to 0. So let's handle the easy part. So this one will be a 0. And then what else? And then the derivative of x squared is what? The derivative of x squared is 2x, right? So this one will be a 2x. And then how about the derivative of y? So the derivative of y, here is how we are going to do it. So follow me. The derivative with respect to x. However, I have a y. How do we take care of this situation? Listen to me. When you take the derivative of this, just treat y as x. You do the derivative anyway. So just assume, all right? Y is x. So let's say you are taking the derivative of x squared. What do you have? Then you have a 2x, right? 2x. But you have a y in here. So how about this? We are going to put the x back to y, and then we mark this a dy dx. So that is the result of the derivative. You might be wondering, hey, why do you do this? Like, who came up with this? There is no way that I can come up with such kind of thing. Here is how. So let me switch color to show you how. So this is what we just do. So we have the derivative with respect to x of y squared. All right. So now let's break down the d dx and the y squared. Here is how I'm going to break it down. I'm going to do a d and then a y squared and then a dx. So if you multiply everything in the fraction, so you have d on top, d, that is not a dx. Yes, that is a dx. I'm not supposed to erase it. So you have a d on top, a dx on the bottom, and then a y, right? Now, I just split the fraction to make it look like this. But I am missing a denominator. I am missing a numerator. How do you add the missing components in? So here is the missing component. You have a dy, you have a dy. So just consider the multiplying fraction. Do we agree that the dy and the dy can be cancelled, right? So if you cancel the dy and the dy, then you only have d over dx and then a y squared. So and then now you consider these two. What I am asking you to do. I am asking you to take the derivative of y squared, right? Okay, easy. I can do that. So that is 2y. The derivative of y squared is equals to 2y. So what about the leftover? This is the leftover, right? So you bring the dy dx over, then that's it. So the phrase I use for myself when I was a student, implicit differentiation, this is how I say this to myself. When I take the derivative with respect to x of y squared, I take the derivative anyway. I treat y as x. But when I do the writing, I write y instead of x. After this real procedure is done, I will stamp my work, stamp a dy dx right next to the result. Let's do this again. When I take the derivative of x, when I take the derivative with respect to x of y squared, I treat y as x. I do the derivative anyway. When I do my writing, I write y instead of x. After this real procedure is done, we of course repeat quotation mark because we are doing the right thing. After this procedure is done, I make a stamp, I make a mark for myself. That mark is called dy dx right next to the real stuff I just did. So here, that is how I think about implicit differentiation. All right, the job is not done. So we have 2x plus this. And then what we are trying to do is I am trying to put the dy dx on one side. So the dy dx, so we have 2y. I should follow the color, right? So we have 2y dy dx equals to negative 2x. And then yes, you are very smart. I know you can divide both sides by 2, or you divide both sides by 2y. So dy dx is equals to negative 2x divided by 2y. So dy dx is equals to negative x over y. That is the result. All right, so that is the result. All right, so that is the basic introduction of implicit differentiation. In the next part, I will show you more examples. So in order to teach you how to do implicit differentiation. Don't forget, give me a like, subscribe, share the video. I see you all in the next part.